Okay, question number 14 on our Test 3 review for Math 1105. What you're given is a position function. Now remember, position function tells you where an object is located above the ground at a particular time after it's been released or thrown upward or whatever. And this position function happens to be quadratic. And let's look at the function so that I can explain to you how we're going to begin to answer the question. Here we are. The position function, s of t, is equal to the opposite of 16t squared plus 150t plus 40. If you were to graph this, and again, not accurately, but if you were to just do a rough estimate of what that graph would look like, we know that it's because it is a quadratic function, it is a parabola, and we know that it's going to open down because the leading coefficient is negative. So what would be happening is at the vertex, if I located the vertex, what would be happening at the vertex would be the maximum y value of this function. So this particular problem asks you to determine the maximum height of the projectile and how long it took to reach it. So what they're really asking us to do is to locate the vertex. The input value will be the time and the output value will be the height. So to locate the vertex of a quadratic function, we can use the vertex formula to find the vertex. Remember, there will be two coordinates. Now this time, rather than saying x is equal to the opposite of b over 2a, I'm going to say t is equal to, since t is represents the input variable. So t is the opposite of b over 2a. T is equal to the opposite of b is 150 over 2 times a is a negative 16. Now, if you take out your handy dandy calculator, what we're actually going to do here, the two negatives cancel each other out, and 150 divided by 2 times 16, which is 32, I did this on my calculator earlier, turns out to be 4.6875. So it's not a pretty coordinate. 4.6875 is the input value of the vertex. So far what I know is this. It takes the object 4.6875 seconds to reach the maximum height. Now, to find the maximum height, I actually have to find the output value of the vertex, because of course that's where the maximum height is. So I need to take this number, 4.6875, and plug it into the position function. I need to find s of 4.6875. And this is when we are very grateful for calculators, because we have to find a negative 16 times the quantity 4.6875 squared plus 150 times the quantity 4.6875 plus 40. In other words, what we did is we plugged 4.6875 into the position function. And now when I pull out my handy dandy calculator and I do this computation, I get the answer 391.5625. 391.5625. So to answer my question, this number is measured in feet and that number represents the maximum height. That's the highest this object reaches. And the input value, 4.6875 seconds, is how long it takes to reach the maximum height. And we're done. And again, thank goodness for calculators.